So today we will be discussing another set of problem as we have discussed in the previous class. Okay, so let us come to the problem number 1. Again I am repeating, these problems are taken from the Conscience Physics book ICSE class 10. So we are solving some numerical problems related to moment of force. Let us come to problem number 1. It has been said that an uniform half meter rule can be balanced at 29 centimeter mark when a mass of 20 gram is hung from its one end. So first of all, you have to draw the arrangement. The first part of the question asks for the drawing of the arrangement, and the second part of the question says that we have to find the mass of the half meter rule. Okay, so let us first draw the arrangement. So first of all, it is a half meter rule, remember. So solution 1, let us consider solution 1. Okay, so it's a half meter rule. Okay, so let us draw the diagram first for the half meter rule. Will The arrangement will be something like this. Let us say this is a half meter rule. Okay, fine. Now the half meter rule, it is said, is pivoted at its midpoint. I think it was given at the midpoint. Yes, no, it is balanced at the 29 centimeter mark. Okay, so let us, if this is the midpoint, consider this to be it is the midpoint. Okay, then 29 centimeter is slightly to the right of it, because this is a half meter rule. Hence the total length of the rule is 50 centimeter, isn't it? So half meter rule 50 centimeter, midpoint will be 25, 29 will be just on the other side of the right side of the 25 centimeter mark. Okay, so here it has been pivoted. So let us see, this is 29 centimeter. Okay, this is 29 centimeter. Let us mark it out, 29 centimeter. Okay, fine. Now if I consider, it has been said that the mass of 20 gram, here it is given mass of 20 gram is suspended from the it has been asked where should the mass of 20 gram should be suspended. Okay, so first of all, let us think that the weight of the rule, as I have discussed in the previous class, weight of a meter rule, or say here half meter rule, will always act to its midpoint. So midpoint of a half meter rule is 25 centimeter, definitely. So the weight of the rule will be acting through this 25 centimeter mark. Okay, so this is a 25 centimeter mark. So this is the point where the weight of the rule will act. So this is our 25 centimeter mark. So just write it, just write it to avoid any kind of confusion. Okay, this is 25 centimeter mark. Centimeter. Okay, 25 centimeter, fine. Now as we don't know the weight of the rule, let us consider that the weight of the rule is WGF. So we can write a WGF here, WGF. Okay, fine. Now, so let's just think, where should the 20 gram mass should be suspended. It has been in the problem, it has been said that the 20 gram mass is suspended from one end, but it has not been mentioned which end, right end or left end. So definitely here the weight of the rule tries to rotate the rule in the anti-clockwise direction. If I consider the pivoted point to be O, this is point O. Okay, so considering the point O, the mass of the weight of the rule tries to rotate it in the anti-clockwise direction. Okay, so definitely if I want to balance the rule, I have to suspend the 20 gram mass on the right end. Okay, isn't it, right end? So this is the 0 centimeter mark, this is the 50 centimeter mark, and from this 50 centimeter mark the weight of the rule actually, sorry, the mass 20 gram actually acts. So here is the 20 gram mass. So you know all that. If I say that the mass is 20 gram, then if I say that the mass is 20 gram 20 gram, then I can say that the weight of the body, weight of this object will be 20 gf, isn't it? So I can write 20 gf without doing any kind of conversion. So I can directly write that the mass being suspended, the weight being suspended, weight acting at the 50 centimeter mark is 20 gf, whereas the weight of the rule has been taken to be as wgf. Okay, now, so this is the first part of the problem where we have drawn the arrangement. Now coming to the second part of the problem, we have to do the solution and find out the weight of the rule. So first of all, let us this is the part A of the question. So this is part 1 of question. Next is the part 2 of the question. We say that, what do you say here? We say that the rule is balanced condition. So for that there must be two moment, one anti-clockwise and clockwise definitely. So what is the clockwise moment? Can you say, can you just think of what is the clockwise moment? The clockwise moment will be created by this 20 gf force, isn't it? The clockwise moment will be created by this 20 gf force, isn't it? So total, so I can write cw, clockwise moment due to 20 gf. Let us consider this as m1. Okay, m1. So that will be 20 into, I can write 50 minus 29, 50 minus 29, 50 minus 29. Why I am taking 29? As because 29 centimeter is my pivot point. So it comes out to be 20 into 21 gf centimeter. Okay, fine. Now what will be the anti-clockwise moment? ACW moment. Anti-clockwise moment, anti-clockwise moment due to the weight W gf. Let us consider this to be m2. Okay, so this will be equal to how much? W into distance will be 29 minus 25, that is equals to W into 4 gf centimeter. Right. Now as the meter rule is balanced condition, then obviously by the principle of moments, so by principle of moments, by principle of moments, okay, our m1 will be definitely equal to m2. m1 will be equal to m2, isn't it? Yes, definitely. So we can write m1 20 into 21 will be equal to w into 4, isn't it? W into 4. So from this you can say, or you can say that W is equal to 20 into 21 by 4, isn't it? So doing the calculations, it turns out to be 4 5s are 20, and 5 into 21 is 105. Okay, hence you can say that the weight of the rule, we can write it as weight of the rule, weight of rule is 105 gf. Okay, in the question it was asked find the mass of the rule. Okay, so if I consider mass, it will be only 105 gram. So definitely mass will be just taking the numerical value, mass will be equal to 105 gram. Okay, so this is the solution. So I think The concept is clear, isn't it? Okay, now let us move on to the next solution.